Hi guys. Just a quick check that you can view my screen and you can hear me. Okay. Uh, Seems like, am I audible to just one person? I mean, just a single person. Mahesh has replied that I'm audible and he can view my screen. Guys, yes, no, maybe, so that we can begin. We have limited time frame. We have to cover a lot of things today. Okay, Shalini says yes, I'm audible. Okay. I believe you can view my screen as well. Okay, Preetam says yes as well. All right. Seems we're good to begin. Okay, Krishna says yes as well. Okay, so we are here to have a very interactive discussion today about Apache Solr. Let me quickly introduce myself. I am Atita Arora, and I'm working in IT industry in development and leadership roles for last 9.5 years. So I began using Apache Solr way back in 2008. So began using it in version 2.2. So that was the time, I mean, we had real, tussle with using Lucene and Solr because they used to come in different distributions altogether. So we had a very tough time at that phase. So on this note, we'll simply go ahead and begin with what we are supposed to be discussing today. So let me just start the slideshow. Okay. So I welcome you all on behalf of Edureka. So we would be discussing how can we leverage using Apache Solr and Lucene to boost the search utility in the application. So I hope all of you must be from the web application backgrounds. That is why you guys are here. So I'm sure we surely have something to take away today from this webinar. So these are the modules which we are covering today in this webinar. So the first one is why do we need these search engines for an enterprise grade applications? So what is the importance of search and the objectives and challenges of a search engine when we are implementing the search functionality in the application. Also, what is exactly indexing and searching and why would you really need them in the application? So if at all you're implementing search functionality using Solr or Lucene, what exactly is indexing and searching and how exactly are they jacked up into the application? Then how is this indexing and searching thing handled in Lucene? Because you might notice that we would bring up Lucene quite often in the topic because Solr instead is built on top of Lucene's API. So this is a complete package which has used Lucene's API. So guys, just quick expectation I'm actually setting up here, that if in case you have any questions, please post them on your questions window. So we will take a logical break in between. After discussing few topics, I would check the questions window. So because we have a designated timeline, it is supposed to be completed in 60 minutes. Though over and above is I'm pretty okay with it. But then we would take a logical break in between for the questions. So I'm not going to stop for all the questions which you're going to ask in between. However, I'm not going to ignore any questions as well. We're just going to take them in between the logical breaks. I hope which is pretty much clear. Though I'm going to ask questions as well. I might take your opinions as well. So you can use yes, no, and maybe smileys as well, just to ensure that you guys are with me. Is that clear? Are you guys with me? Yes, no, maybe, smileys. Okay, great, Rahul. Okay, great, Shashank, Mahesh, Krishna. Okay, all right. So then what exactly are the Solr's features and what exactly is Solr? Then we would be discussing about schema of Solr and how is that structured. Then how do we achieve big data NoSQL using SolrCloud? Because SolrCloud is the most recent additions to the Solr. So again, we would be seeing how can we achieve the big data and NoSQL facilities and the capabilities which Solr can deliver through the new implementations. How can we leverage Solr's capabilities with Hadoop? So we would be discussing that as well. How can we integrate two of these? So along with that, the most important one, maybe that is the reason anyone would go for any certification, is that what are the job opportunities for the Solr developers? So any doubts on the topics which are supposed to be covered? Anything else you might want to discuss? You can raise up the questions. So we would be here to discuss them. Okay. So first of all, on our agenda was why do we exactly need these search engines? So imagine if Google was not there. I mean, how would otherwise, you would have searched for the stuff if you wanted to look something online? Any guesses? How would it be without Google? Working in an IT industry without Google? Any guesses, guys? Would it be easy? I mean, if you have to work without Google, if you have to search for something and if you do not have anything which can assist you in searching, how it would be like? Will it be good? Yes, no, maybe, guys. I hope you're not sleeping. Yeah, Shashank says no. Krishna says very difficult. Absolutely. So, absolutely. Preetham says no. Rahul says very difficult. Vijay also says no. So, absolutely, guys. I mean, if you do not have any search engine, imagine you would have to go through looking into each file, because ultimately the stuff which you're looking for is stored in the files, in the form of files, or in the form of a record. In case of any traditional application, we used to maintain a database. And on top of that database, we used to run through our applications, wherein the application used to expose a search box to you on the web application. And through that box, you could search for the stuff you might be looking for, or any information which is there stored in the database. So that search which was exposed by the traditional applications had very limited scope. I mean, anyway, if you would, consider yourself using, maybe a MySQL or an Oracle, search utility. I mean, if you have to look for a, text, a text in the database, you have very limited number of operations available. And overall, if you have to use something like a NLP, natural language processing, or a free text query, that would be even more difficult, because Oracle and traditional databases and stuff, they do not really provide you with a lot of robust support for the free text queries. So free text query, if you guys are not able to follow in case, so free text query is like, I'm looking for maybe a red jacket with blue buttons, something of that sort. I mean, a person can come in and can type anything. So it could be using the punctuations, it could be using any auxiliaries in any English language. So that provides your user to use that search box in the manner they would want to, generally like ask in the store. So it's a free text query. So you do not really, use the conditions, and you give them a logical operator and stuff, that I'm looking for a red jacket and buttons equals to, blue, something of that sort. So you just type in a normal query and you just look for the stuff you're looking for. So over here, if you look into, we have included a snapshot of a very popular website. I'm sure every one of you must have seen something of this sort. So we are seeing over here that the person is looking for a quad-core mobile. So if you look here, there's a suggestion box which has come below the search box, that are you looking for the quad-core mobile phone with KitKat OS, or the Sony mobile phones with quad-core processor, or the quad-core mobile phones with the 4.5-inch screen. Also, it is also listing the popular products which are also related to the search string which has been entered by the user. So if you look here, even if the person, does not really have the exact context of what he might be looking for, there is this search utility which is auto-suggesting. Also, in this case, you might have seen that we have this feature in Google that if you are looking for a certain type of word, maybe say Samsung or maybe Edureka, and you have misspelled it, so it would generally ask you that, do you mean this? I mean, it would, I mean, this is the implementation which you might have seen pretty often on Google, that if you type something and you have misspelled it, it would give you the suggestion that, did you mean this? Have you ever noticed that, guys? Have you ever noticed? Yes? Okay, Rahul says yes. Okay, Krishna says yes as well. So, right, so that is the kind of features which, gives you a very nice user experience as such, and would enable your users to use your website pretty often. It gives you this nice, feel that even if they type something incorrect, there's a system which is there to check. There's a system which is yet to understand the query. They would understand that this is probably what the user means, right? So this is, I would say, the little extension of what we were discussing, that along with the spell correction, it is also extending the user query with few of the suggestions. So suggestions and spell checking, these are the few of the things which a user might want to have on the search box, that the user has been suggested that probably you might be looking for this stuff, or might be using or might be looking for these kind of features. Along with that, the search which you have entered on the web application, in this particular search string, these are the few of the popular products which are related to this particular search text which you have entered. So that kind of makes it easier for the user to reach to the product of their choice, or what they're looking for exactly. Along with that, if you might have noticed, on the left hand panel of all these e-commerce website, that this search thing is pretty popular on the e-commerce website, because you have lots and lots of products. You have millions and billions of products therein. And imagine if the user has to go through each of the product to look for a product of their choice, it would be very, very difficult. I mean, it would not really give them a very good user experience. So such things, I mean, when talking about search as such, is very, very critical on such applications, where looking for a particular product with few of the features is very, very desirable. Along with that, these are the kind of few additions, like the faceting or grouping, I would rather say. So these are the kind of filters from which the user can basically filter out the results of their choice. So I might have entered something like quad-core mobile phones, and I might have said that I'm looking for a mobile phone in the range of 10,000 to 18,000. So it is also giving me the exact count of how many products it has in these categories. Along with that, if I have any brand specification, I can further narrow down my results. If I have any operating system choice, I can further narrow down my results. So it is basically saving users time, and also helping them to filter out the results, so that the user has a smaller data set to look into. Along with that, if you look into the right hand side, is listing all the popular products in this particular category, or for which are pertaining to this particular search results. So these are few of the other popular products in this category. Along with that, if you notice, all the search results which are rendered from this particular search text, all the products are listed here, and everything which a user might want to know at a glimpse. I mean, when I'm looking for any particular product, I would like to know that what is the name of that product, what is the user rating of all the people who might have used that particular product. I might want to know that which category they might fall into. If I'm looking for maybe say apparel range, and I simply said formal shirts, so I might want to know that if it's a female, if it belongs to a female category or a male category, and what is the price range of that particular product. Along with that, I might list out few of the features as well. So this is totally on the presentation layer, like how do I want to show my product. But overall, these are few of the key features which everyone would want to have on their search functionality of the web application. Do you guys feel there should be something else as well for the search functionality? Anything else you feel like? So that's more or less what a user basically expects when they're looking for a search box which has been implemented on any web application. Anything else, guys? Yes, no, maybe? Are we guys good up till here? Any additions? Okay. Mahesh says no. Okay, good till now. Rahul says, okay, Preetham says good as well. Okay, all right. So let's quickly see that what are the few of the bifurcations which we have made on the screen. Like this is the search box, which is going to provide you with the text-based search. So this is basically our interface to the search system, user's interface to the search system. So this is where we put what we are looking for. So this is the text search or the free text search, I would rather say. These are the filters on which I can filter out the documents of my choice. So could be price, could be brand, could be operating system, could be some of the other features as well, like screen size, could be something like maybe delivery area, or I cannot really think of all the other filters. I mean, there are many filters for the matter of fact. You have screen size, you have screen material as well, you have OS version as well. So these are a few of the things by which you could filter out the products of your choice. Along with that, each of the product which has been listed here. So this is, we are naming this as document. So all the products which come in the results, they are been listed as documents. Clear? So what exactly should be our search engine like? I mean, to have a search engine, you need to have a storage engine to search records. So the basic difference, which none of you has really asked me, but I would like to tell you the basic difference. I mean, I have spoken about Google to begin with. So the difference between Google and Solr, which has been implemented on your application, the big difference is that Google works on the flowing data. Like you have off and on, the data has been continuously added to your Google servers. However, in Solr works, it has all the features which are there on Google search. So you can implement that on your website as well. But Solr has this limitation that it is going to work on the standing data. It is going to work on the stored data. It is not going to work on the flowing data. So we would have to maintain the indexes. We can duly push the data continuously, but it is still going to work on, or it is still going to fetch the result set from the standing or the stored indexes. It is not going to pull the data from the flowing like data type of resource. Okay, is it clear, guys? Is the demarcation clear between Google and Solr? More or less the features remains the same, right? It is also going to pull out all the documents. It is also going to provide you with the filters. It is also going to provide you with all the other auto suggest and spell checking and other features. So you can also look for the similar things. You can also boost your particular documents. So you can have all set of features which Google probably has, but the only limitation is that it is going to work on the stored data set. So it only queries the designated resource of indexes. Okay, great. So if you need a storage engine to search records and documents using text-based keywords, it should ideally support the following things. Like it should be optimized for faster text searches. So if you look into the text searches which is based out of Oracle or MySQL or any other traditional databases, you have very limited number of operations which can be done on such traditional databases. So you have operations like and in. So these are few of the functions which you could probably use to look for the particular text in the data set. So again, the limitation is there, plus the text queries are generally bound to be very slow on traditional databases. So again, the first thing which we would like to achieve is that it should be faster. It should provide us with the faster search results which are based on text which has been given by the user. It should also have the flexible schema. So imagine if you are indexing the data of a mobile phone and if you are indexing the data of a washing machine. Obviously, the fields and the features are going to be very, very different. They're going to be very class apart, I would say. So you have features like if you might have indexed something like a screen size, that is not very relevant to a washing machine, obviously. So washing machine is going to work on, it is actually going to have a field like load capacity, which the phone probably might not have. So it should ideally have a flexible schema to ingest all the kind of fields and all the kind of data which can come from various sources. So you should have the arrangements or the schema to adapt to all the kind of documents. So it should also support the sorting of documents. So necessarily you need to have some algorithm by which you could sort out the data as well. So that's one thing which users might be looking for, to add on to all the filters and rest of the other features which we have just discussed. Along with that, there might be features like I'm actually wanting to see only the popular products, or I'm wanting to see the price range from high to low or from low to high. So the search engine should ideally support the sorting of documents as well. Along with that, it should be web scalable, which means that it should be optimized for reads. I mean, you would want to implement a search capability on your website, and you would take a step ahead and would want to implement systems like Solr or Lucene or Elasticsearch or anything that could be. So why would you want to do it? Because you would expect that a lot of read traffic is there on your website. Like a lot of reads are going to happen on your data set. So it should be optimized to handle that read traffic. It should be able to handle all your search requests. So it should be web scalable. Along with that, because we're talking about seeing one document, I mean, like we're talking about the things which could be achieved on each document. So it should be document oriented. It should be able to ingest all the records in the form of a document. So guys, you do not have to really get confused with the documents and the records which we have been discussing. So I would just like to bring up a small point here, that in traditional databases, we used to call them as records. So whenever you used to search or whenever you used to give a query, you used to collect them in the record set, right? Any disconnects here? In the similar manner, Solr works on documents. So it is going to return you the documents, not the records. So it necessarily means the similar thing. Your records used to have the columns, and your documents are going to have fields. Is it clear, guys? Records and documents, fields and columns. Okay? Okay, Ravi has a question here. So does that mean Solr is not good for performing the search for streaming data? Ravi, in case if you have the streaming data request, which is supposed to be rendered by Solr, in that case, it is a good choice. So it generally helps you with that. You can have the streaming data support as well from Solr. However, if you have the data which is coming in, like you have a source which is continuously adding the data to your indexes. I mean, what my point remains here is that it is going to work on the index store, which is the standing data. So you could probably have another, say, source which is adding the data onto that index store. But in that case, you cannot, promise that all the data which has been poured in, that is going to be available in the search results. So there has to be some timeline that that data is going to be prepared for, and it is going to be available for search in the search results. Does that make sense, Ravi? Yeah, Rahul says that means that there is a lag in the data coming in and getting indexed. Yeah, there has to be a lag, Rahul, because we generally perform a lot of operations on the data which is coming in. Like the data has been fetched from a particular resource. Like we might be crawling through the, web-based data, and we would be collecting all the documents, which are then converted, and they're broken into tokens. And the analysis is going to be performed on those tokens, and then only it is going to be pushed inside the Solr server. However, we have the near real-time searching feature as well there. So we would be discussing about that as well in a little while. Yeah, so overall, Solr is good for standing data, because we have a lot of things to be performed before the data has been finally pushed in the index store. So we would be discussing that as well. So this is a small example from a ClearTrip spatial search. So for using the similarity between two text, like you might be looking for some feature like that. I'm looking for terms or the product which are closer to this one, like the one which we have just discussed, like a few products or few similar products according to your product of choice. You have similar products like these. So there's this Levenstein algorithm which works at the back end, which identifies that how close two documents could be. And for spatial records, like the space records, which essentially have latitude and longitude points, for this, Solr uses Haversine algorithm. So if we were supposed to be there in a regular class, we would have discussed about these algorithms. So this is supposed to be covered in the due course of time when we have discussions. We have a dedicated modules for these topics in the Apache Solr course with Edureka. So then what exactly is Lucene? Before that, I guess we have some questions. We have a question from Uday. Can we have contextual search in Solr? So I'm not sure what exactly you mean by contextual search in Solr. I mean, do you mean the similar context? Something of that sort, Uday? So that context needs to be defined, that needs to be indexed. So if you have something like a field which necessarily would contain the context of a document, we can definitely pull out all the other documents which have the similar context. Yeah, that's right. So if query 2 is related to query 1, okay. Yeah, that can be done in Solr. That very well can be supported. Ravi has another question. What is the basic difference between Solr, Lucene, Elasticsearch? I see these terms are used together. Yeah, they are used together because all of them are basically revolving around search. So at this particular time, I can say is that both Solr and Elasticsearch are very popular options for implementing search in the web applications. Both of them are based out of Lucene. So both of them, under the hood are using Lucene APIs. So Elasticsearch initially had this, edge that it used to provide the near real-time search support. However, after version 4, that was supported by Solr as well. Another thing I would like to say here is that Elasticsearch does not really offers you a lot of flexibility in terms of the data format which could be ingested in the server. Like you just have to send across the data only in the JSON format. So Solr can take the data in XML, JSON, you have Perl, Ruby, you have CSV. So you can ingest the data in all these formats. So along with that, you have Apache Tika, which can be integrated in Solr, and it can read the data from almost all the sources. I hope we are good with that demarcation, Ravi. Are we good with it? Okay, great. So Sandesh says, okay, would you be recording this webinar? Yes, that would be recorded, Sandesh, and that would be available that would be distributed to you guys. I'm not sure if you would be able to download it. I'm not really sure about that. However, it would be distributed to you. You can view it online. So it would be posted on the blogs as well for Edureka. Okay. So, okay, does Lucene has .NET API SOAP calls for .NET? Yes, Preetham, it has that. I mean, Lucene has the .NET version as well. It has been supported by all the programming languages which are, indexing capable. Okay, then Uday has, I think Uday, I'm sure your question must have been answered by now. I mean, we can definitely support these. Okay, all right. So any guesses on who this guy could be? Anyone who recognizes this guy? Dough cutting? Do you guys recognize him with Hadoop? Yeah, Ravi is the first one to answer that. So had this been the physical class, I would have given you the chocolate, Ravi. So except virtual chocolate. So great. So great. After that, I guess we have Rahul and Saikat who has answered this question. Okay. So Lucene is, this is the guy who created Lucene, and he has named, if you might have seen one of his webinar where he's discussing why did he named this particular search library as Lucene, is that it is basically an extension of his wife's name, Lucy. Okay, so this is a very interesting thing, in fact. So Lucene is basically the very powerful Java search library that lets you easily search and add search or information retrieval to the existing applications or the new applications. So the major thing which revolves around this is that it works around the information retrieval. So if you might have taken a look into LinkedIn, Twitter, and the other websites, you might have noticed that they work around the text searches. So all the websites which you might have seen, they work on the text search are the ones which are using Lucene or some extension of Lucene at the backend. So maybe when this presentation is going to be distributed to you guys, you can click on this link and you can see that what all websites are being powered by Lucene. So it's very, very scalable and very, very high performing indexing API. And it gives you the powerful, accurate, and efficient search algorithms at the backend. It offers you the cross-platform solution as well. So overall, as of now, it's open source and 100% pure Java. But you have other versions of Lucene as well, like Lucene.NET is also available. And you have Lucene's Python version as well available. There are a few other programming languages in which Lucene is available. So any language which supports indexes, we have the version of Lucene available for that. Okay. So we have been talking about indexing quite a lot. We have been talking about that the document, is picked from a resource wherever it is supposed to be picked up from, and it goes through the process of indexing, and then only it is available for searching. So what exactly happens in this process of indexing? So how does that really works? So if you look here, we are talking about these three documents here in general. So we've taken a very small example just to understand the concept. So try concentrating on what the concept is instead of looking into what has been indexed and stuff. So we have first document which says I like Edureka courses. The second one says Edureka teaches big data courses, and the third one says Edureka helps learn new technologies easily. So if you look here, we have few key terms which are there in each of these documents. Like the first one has Edureka and courses. We are simply going to ignore, and in fact the analyzers which are written for Lucene's process of indexing, they are going to ignore the common English terms. Because often on lot of documents are going to have those words like a and has, been, like, I, you. Such words are very, very common, and they quite often occur in most of the documents. So that is why we assume that such words or such terms do not really add any value to any document. So that is why we simply trim them off at the time of indexing. Do we understand? Do we understand that, guys? Why do we trim them off? Yeah? Okay. Great, Rahul. So we have picked up only the key terms from each of the documents, and we are going to maintain this cross-reference lookup. I hope you guys do remember that at the time of reading the textbooks in your school, you had two type of indexes. Like the one was the front of the book index, and there was this other one which is back of the book index. Do you guys remember the back of the book index? So this is something like what Lucene does as well. Is this something which you recognize? Is this how it used to look? So you have all the important concepts, and you have the page number on which they've been described, right? The anglerfish and the bird is there on 6, 7, and 28 pages. So this is the similar thing which Lucene does as well at the back end. As well, what it does is that Edureka and courses were there in document 1. So that is why whenever it is going to list out all the important terms, it is going to maintain the reference of the documents where they appeared. So at the time of the user looking for a query, it is not going to look for this particular word in all of these documents. Otherwise, it is going to become a flat file scan. So we're not working on that concept. We are working on inverted indexes. So these are the inverted indexes. This is how it used to look like. So whenever a user is looking for anything, any text, it is not going to be sent to the documents. Instead, they're going to be sent to this cross-reference lookup. So imagine looking for such 10,000 documents and instead looking for this small cross-reference lookup table. That is why it is very fast. So it is not looking for this particular text in all the documents. Instead, it is looking for the text in this cross-reference lookup. So it is simply going to look into if this document, if this particular text was there in any which all documents. It is simply going to look into this, and it will find that this particular term was found in document 1, 2, and 3. If somebody might have been looking for big data, this might have found document 2 as the reference. Do you guys understand the inverted indexing methodology? Like what is happening at the backend? Why is it so fast? Why is it like blazing fast? Because the text and the free text searches are not evaluated on each of the files. Instead, they've been searched and worked through with this cross-reference lookup. Is it clear, guys? Yes, no, maybe? Any confusions here? Okay. Yeah, Cycle says tag to a document. Preetam says yes. Ravi says yes as well. Okay. Yeah, that's more or less, I mean, you have tagged your terms and the documents together. So a table which is maintaining all the important terms and the document reference, so that user does not really has to go into all the files separately looking for a text. Instead, it would simply go into this cross-reference lookup. No, there is no MapReduce running at the backend for these processes, Rahul. But we definitely can have something of that sort. I mean, when we are integrating Solr and Hadoop, we can definitely have something of that sort. However, we just have the process of analysis, and this happens in the process of analysis only. That is why we say that it takes some time for Solr to finally, reflect a document when it has been pushed for indexing. So I believe every search engine is based on inverted indexing. Ravi is asking me that. Yeah, more or less, yes. I mean, this is something which is a very efficient mechanism to support the real-time queries and real-time, search results. So yes, this is something as a concept-wise, yes, this is something which has been used by all the search engines. So that is correct. So these are few of the classes from the package which have been used at the time of indexing. So we have spoken about a record and the document similarity. So a record essentially has the columns. So a document which is there in Lucene and Solr, the search results are going to be rendered in the form of documents. So each document is going to have the list of fields. So these fields are supposed to be monitored by your schema.xml which you provide with Solr. This goes through the process of analysis. So for this, you can pick out an analyzer which is available in the package already with Lucene, or you could write your own custom analyzer. So had this been a real class, I would have told you how to write a custom analyzer as well. Like you might want to have some of your own features in the analyzer, or some of your own ways in which you would want to analyze the text which is coming in from the sources. So you could write them here. So you have document, you have fields, a document which consists of all these fields that goes through the process of analysis, and then the instance of index writer has been given, and the reference of this document has been passed in, and they've been written to the directory, and they've been stored in the directory. So this directory could also be the be of your choice. Like you could be using a normal file system, or you could be using a network file system, or you could be using a Hadoop file system as well. So you could specify the directory of your choice and you can dump in the indexes. Clear? Is it clear, guys? Meanwhile, we have a few questions. Let me just let me just take a small pause and then we can take up the questions. Okay. So what is the process of searching at the backend? I mean, vis-a-vis the process of indexing, we have the process of searching as well. So for searching, we need to have something which can understand what kind of query the user has given. So we necessarily need to have some mechanism, some sub-process which can convert our free text query into the query which Solr can understand. So we have this query parser, which basically translate the textual expressions which have been given by the user, and they are converted into the arbitrarily complex query which Solr would understand. So you have expression, you have a query parser which works on top of these expressions, and they're also analyzed as well. Sorry. So you have the query parser. So in Solr, what happens is that all your documents which are pushed inside the index store, they are also analyzed. Along with that, your queries are also analyzed. I mean, you would never want to have any abusive word or any, obscene thing which could be searched through your website. So this is something which can be controlled with this, analyzer. And your query parser is basically going to decide that how your query is going to be understood by the Solr system. And then after this, a query object has been prepared, and then it has been rendered through your index searcher. It has been passed to the index searcher, and then this index searcher is going to return the set of documents which are pertaining to your query. Okay. Let's take few questions at this point in time. I believe there are a lot of questions. Let's see that. This inverted index is good for document that contains sentence. How about integer type data? Saurabh is asking me. So okay, so Saurabh, we have the field types. So let me just show you the sample, schema.xml. So this is the sample schema.xml, wherein you can define what kind of fields are you expecting, right? So if you have this integer type of data as well, that is also stored as the fields as well. So these, you have these analyzers by which you can basically, attach the document reference with the integer type of data as well, right? Is it clear, Saurabh? However, you have all the, there are few analyzers which are basically going to trim off all the, integers as well. So you have different type of analyzers. We have a complete module dedicated in the course to understand these. Okay. Okay. Ambrish says, what program does this invert? I quite didn't get you. You're asking what basically triggers this, or I mean, is there any daemon which maintains this inverted index? Okay, so you have this, see, every time you push, you would have to basically invoke the indexing procedure. So you have various ways by which you could, invoke the indexing procedure. So you have this Java class, which is, basically at the back end is converting all your document data into the indexes, or in the inverted indexing, I would rather say. So you would have to invoke this, subroutine through maybe a jar file or through, web routine. Like you could send in the data for indexing through the web source as well. So we would be taking some example of that as well. However, if you have something like you're expecting that data is going to be, feeded in like fortnightly, you can also write a cron job. However, at this point in time, just to make things a little simpler, we have few of the ways like a jar file from where you can specify the source of the document and you can push in the data. And you have the web source from where you can basically provide the data, the field data, and you can simply push in for indexing. However, you can write your own daemon. You can have something of that sort. Is that clear? Amrish, is it clear? Okay. All right. Ravi says directory is not depicted in this diagram. Index searcher must be talking to directory to get the results. That's right, Ravi. We've not really maintained the back arrow as well. So index searcher is basically going to render the documents back, to the UI as well. So that is not the complete picture. That is the classes which have been used. Okay. Okay. After this, interestingly, both Solr and Elasticsearch are built on Lucene search engine. That's right, Pramod. Okay. Nishu has a question. How to extract fields from the human input to form the Lucene query in case if user is giving complex sentences. So, okay. Nishu, we have this query parser. This is the job of the query parser, how this data is going to be extracted in the format which the Solr would understand, basically. So you have various type of query parsers. Again, we have a complete module on this as well. With the Solr course from Edureka, we have a complete module which talks about all sort of query parsers available. So you could explicitly invoke the query parser. You can specify that in the query. However, you have this way by which you can let Solr use or choose the query parser of its choice, and you can basically let Solr deal with the data. I would not be able to discuss that in detail, Nishu. I'm so sorry, because we are anyway running out of time and we have few more slides to cover on this. If you're left with some time in the end, we can probably discuss that, but it's hell lot of detailed topic. Okay. So Rahul has another question. Do Solr have in-memory like memcache as well? All data resides on the file system. Well, okay, Rahul, I believe you're looking for the addition like it generally does not has its own memory. It is going to be deployed somewhere, like the Solr distribution is going to be placed somewhere on some sort of file system. So you can basically choose the data directory. You would have to specify that in the configuration, and then there only the indexes are going to reside. And the queries are going to be rendered, and they're going to be prepared from that particular location. Okay. So let's quickly move on. Okay. So Ravi, I guess I'm detaining the question which you have asked. How do we rank the search results? Not really for any purpose, but because I'm actually going to be discussing that now. So we are discussing that now, so that is why I have not preferred to answer the question. I would rather show it to you. So we have this question from one of the attendees, that how the ranking has been done. So obviously, when we are dealing with the documents, there might be some of our choice that some documents should be placed above the other ones, like how these documents are being arranged in the search results. So this is controlled by the feature called boosting. So you can boost the documents. You can place your one document above the others. So this is controlled by the score which has been assigned to each of the document. So this is called document weight or score, which can be changed from default. So this entire procedure is called boosting. So as the name suggests, we are basically boosting the score of a particular document or particular documents, and we are basically maintaining the position of these documents higher than the rest of the documents. Is it clear? So this can be basically controlled at the time of indexing and at the time of query as well. So likewise, if you are say ingesting a document and it contains some words like say I am basically ingesting from a source, and I'm saying that if the document happens to have a token called Hadoop or big data, I'm saying that that particular field is going to be boosted with some factor, some boost factor. So that is called index time boosting. Okay. So we can call that on each of the fields which have a data which is pertaining to some set, because anyway we would generally have a criteria on which we are going to be boosting the documents. So the document is going to be boosted when the fields containing which are contained in that documents are going to be boosted. So this is something which can be controlled at the time of indexing. However, at the time of query as well, you can set the boost. If your query contains, again, the strategy remains the same. We're going to check with the words or the terms which happen to occur in that query. Okay, so that is what is going to boost the search results. So if you're say if your query you're looking for something like big data Hadoop, and I say that if my document, I'm basically looking for the big data related documents, I can simply say big data, and I can specify my boost factor at that time, that if my document has big data therein, it would be boosted to some factor, so that it shows if a document has big data therein, it is going to be placed way above the other documents. So you can specify that per the clause. So this is something which is again the manual setting, the manual way by which you could invoke the boosting. However, you have the XML mechanism as well. Like if you might have noticed something like a editorial boost or editorial choice, or the sponsored results, something of this sort, if you guys might have noticed on Google. Have you ever noticed this thing? You have something like a sponsored results thing whenever you're looking for something. Like if you're looking for a washing machine, you might have seen that sponsored results, and then Samsung or Sony or some other brand might be showing their products in the very beginning. So this is something which can be controlled through an XML. You can elevate the documents as well. You can boost few of the documents despite any other factor which is there in the query. So you can, there could be few documents wherein you can specify that if a person is looking for a washing machine, show the Samsung washing machine in the very beginning. So this is another way by which you can boost a particular document. Is it clear, guys? Is your question answered, Ravi? Yes, no, maybe? Okay, all right. So how this search system essentially looks like. So if you look here, we have all the components which appear in blue are the Solr's components. So if you look here, we have this source from which we might be picking a lot of documents. So like you could be picking documents from a cron job, you could be picking documents from say a crawler, a web crawler. So that might be crawling through the websites and getting you the content. So this, the first step remains, how do we basically are acquiring the content. Then after acquiring this content, we are basically going to generate the document out of it. So this content is supposed to be converted in the document format. And then this document goes inside for the analysis procedure. Okay, we have been discussing about that. Every time the document has been pushed inside the Solr server, it is basically analyzed first. So in this analysis procedure, we basically first of all tokenize the data, we convert them into tokens, and then we filter out the data which we do not want. Okay, so after this analysis, these documents are basically indexed in the index store, and they are basically dumped into the index store. On the other end, if we have a user here which is interacting with this web console or the UI, from search UI, it is going to search for a particular text. From there, we're going to basically build the query, and we're basically going to run the query. So at the time of building the query parser comes to our rescue, which is basically going to decompose this query which we have written in the format which Solr would understand. And then it is going to run the query, and it is going to, what it is going to do is, it is going to interact with this index store only, where we have dumped the indexes. And then the response has been redirected back to this sub procedure. Okay, and from this, we are going to render the search results in the format which user might have specified. So you have various ways in which you could arrange the search results. So you have a writer type, which basically controls like how do you want to really see the search results in XML, JSON, CSV, or Perl, or Ruby, or maybe some other way in which you would want to see the search results. Or you might be using XSLT as well. You might have some certain specifications from the client by which you would like to arrange the search results, and then you're going to render them through your search UI only. Is it clear, guys? Is the process clear? So Ravi says, so Lucene library seems to be doing core work for search. Where does Solr kick in the flow? Okay, that's a very good question. Well, had this been the regular course, I mean, I usually get this question off and on in my batches. So we have a lot of things which Solr is doing, Lucene alone cannot handle. So Lucene is is the magic which is basically running under the hood, but it's Solr which is going to provide you with all the UI. I mean, Lucene is just a library. So you just import that, you just use it in your code base and you can use the features. However, if you want to monitor the way the things are happening at the back end, Solr comes to your rescue. So Solr is basically dealing with all the administration part, all the management part, and overall, if you want to run in the clustered mode, in the cloud mode, Solr comes to your rescue. It is also going to take care of your cluster management as well. Is that clear, Ravi? There are a lot of things which Solr also is doing, but the core search functionality has been taken care of by Lucene. So we're going to be discussing the architecture as well. I know we are running short of time. We are anyway left with only 5 minutes, but then I think we can hold on the questions as of now. Let me just cover a few things here, and then we can come back to the questions. I hope if that's fine with everyone. So what exactly is Solr? We have a lot of questions coming in for what exactly is Solr. So Solr is basically the open source enterprise search server or the web application. So you can use it as the web application, you can use it as the search server, you can use it as the indexing server as well. So it is using the search, it is using the Lucene's search library, and it is extending it further with all the features like cluster management, the administration features. So basically, Solr is exposing the Lucene's Java APIs as the RESTful services. That's the biggest thing which this guy is doing. So instead of having to implement everything on your own, it basically gives you a simple, Java API, the REST API, and you just simply hit your request. You would simply set the params, and you can simply hit that RESTful service, and you can get your search results. So that is something which has been done by Solr. So instead of you having to do it, it is Solr which is doing it at the back end. So when you put in the document, the process is called indexing. So you can push in the documents in the XML format, in the JSON format, in the CSV format, or you can send in the document binary over HTTP as well. And you can get the response in the similar formats as well through your HTTP GET query. So these are few of the key features which are there. Again, this is a little different from Lucene as well. Lucene does provide you with all the search capabilities, but Lucene also has few of the limitations. Again, this was also covered in the core course. So I'm not sure, because anyway we have a very limited time frame. So we anyway do not have a lot of time to discuss all of these. So Solr has key features like it provides you with the advanced full text search capabilities. You have a lot of query parsers. You have a lot of query types. So you can choose the query type. You can choose the query parser of your choice, and you can let your system understand the query in the manner you would want it to, or you can let the system as well decide that which the way the query has been decoded by the system. It is pretty much optimized for the high volume of web traffic. So it is very robust for high number of reads which could happen on your website. So it provides you with all the standard based open interfaces like XML, JSON, and HTTP. So you can push in the data, you can receive the data in the similar formats as well. So this is something which is little different from Elasticsearch, as Elasticsearch only supports JSON. It provides you with the comprehensive HTML administration interfaces as well. We're going to see how this administration interface looks like. So if you're simply using only Lucene in your application, you would not really have something like this administration console. So you would have to debug through everything just to understand that how things are really happening. However, with this administration console, you can see how many shards are there, like in a distributed system, how are your queries understood by the system and stuff. You can monitor over JMX as well, like how much logging has been done for each of the component, how much RAM, how much memory has been used and stuff. So this is something which Solr enables you to do. So Lucene doesn't really helps you with that. So near real-time indexing and adaptable with the XML configurations. So again, in Lucene, the biggest disadvantage, I mean, if you're using it alone, is that you would have to code everything. However, with Solr, it lets you configure everything through XMLs. Okay, so you can choose the type of schema. Instead of having to write everything in the code, we would be providing that through the schema. So Lucene doesn't really works on the schema.xml, which we have on the Solr. For using Lucene alone, you would have to define that in the code. And every time you would be wanting to ingest a new document, you would have to define them in the code itself. So that's a very stringent behavior. So Solr goes a step ahead and lets you have the flexibility on the schema. Also, Solr is linearly scalable. You can have the indexes replicated. You have this architecture which lets you add more plugins, which lets you add more capabilities. So this is something which is also not supported by Lucene alone. So this is the extension to what Ravi was asking. So there are a few of the giants here which we have listed, which are using Lucene and Solr. So Apple, AOL, I think there's no need to list all of these because I think the logos says it all. So you have all the big giants who are using Solr. So this is essentially the architecture of Solr. So if you look here, the underlying thing remains the same. Apache Lucene remains at the back of the hood. So you have the core search and the core indexing mechanism and the analysis procedure that has been rendered by Lucene only. Along with that, Solr, if you look here, this is actually the entire picture looks like. I mean, Lucene comprises of a very small part in the Solr's architecture. You have hell lot of features which are, there in Solr's otherwise as well. So you have request handlers. So request handlers are the guys which are basically, so these are basically the APIs which have been exposed by Solr. So these are the REST APIs like admin, select, and spell. So this, if you have been exposing the API like /spell, this would be using the search components at the backend. Like these are the separate search components which are going to be used either with the these request handlers or as independent components itself. So you can use them independently. So you have search components like query. You have advanced features like highlighting, spelling, stats, faceting, debugging, more like this. This is more like this. This is a typo here. And clustering. So these are the search components which are basically taking care of all the advanced features which are provided by Solr. So there might be scenario where you are trying to group the search results, like we just saw the price ranges which we were just seeing. They've been rendered by the faceting. You can debug your query as well. You can form the clusters as well. So this is basically using the Caret2 engine at the backend, and it is going to give you the dynamic clusters as well from your search results. So more or less, it is also providing you with the distributed search mechanism as well. Like you could have the clustered environment and your query could be rendered through various nodes. Like you're sending in your search query and the search results are being rendered by maybe more than 2 or 3 or maybe n number of nodes. So that has also been taken care of in the Solr only. So you have other features like faceting could be one of the independent component. Filtering is another component. Search is another component. Caching is another component here. Query parsing, analysis, and highlighting are also independent components. So we have been listed them twice because they can be used independently and they can be used as the search component as well, like in some other component. So this is the flexibility of the architecture again. The request writers are basically going to decide that how the response has been written on the user's interface. So you can write that in the XML format, in the JSON format, in the binary format, and all of this is controlled by the schema and your Solr config XML. So the schema and this configuration is also the key, or I would say the heart of the Solr's instance which has been running at the back end. Okay, then you have the update processes, like if you want to have the security features enabled as well, so you can use the update processors like the signatures one, so they can decide the algorithm by which you can encrypt the data and you can send them in. You have logging and indexing update processes as well, which can basically monitor the data and index the data as well. You have update handlers by which you could make the delta updates to the server. Like if you want to post in more data, you can use any one of these like XML, CSV or binary format, or the JSON format, or some other format. Like you could have, if you have integrated Apache Tika, which has been integrated here, you would have this component integrated by default in your Solr version 4.x. So this is something which is taking care of extracting the data from the documents in the various formats like PDF, Word, XLS, or there could be various other formats. So this API or this component basically takes care of stripping off the data from various sources and pushing them inside the Solr server. However, you have the data import handlers as well, wherein you can import the data from your traditional databases as well. You can write up the configuration and you can maintain the documents by picking them up from your traditional databases as well. Along with that, the SolrCloud version supports the index replication as well, the deduplication as well. So with that, it is basically going to make sure that your data is highly available. You can maintain the replicated data on various servers, and so as to support the distributed search and distributed indexing mechanism. Is it clear, guys? I know that was quite a heavy load of dose, but any confusions here? So you have hell lot of flexibility which is available on your Solr's architecture, which is not necessarily there in Lucene alone. So Ravi has a question for any search-based workflow in the application, should I assume that Solr is here to replace the RDBMS? Yeah, obviously. I mean, if you're talking about replacing it with the traditional searches which were rendered by RDBMS, yes, it is there to, they're definitely going to replace it, because there's a lot of flexibility therein, and you can have the results of your choice as well. Plus, it is very responsive as well. You would have to write a lot of joins and a lot of other operations if you have to run through the similar query in the RDBMS. So the various inputs are being handled by Solr, is taken care of by Tika. Pramod is asking me, you mean the various input formats like PDF, Word, XLS and stuff? Yes, it has been taken care of by Tika. So that is the update processor. So you can invoke that and you can ingest the documents. Clear? So this is how the search process looks like. You have you have this user which is sending in the query. So you can define the query type. So you can basically control the way this query should be understood by the system. After that, it is going to be sent to the request handler. So the request handler more or less is configured like slash query or slash search. So by that you can configure the behavior and you can send in the query on this particular request handler, and you can also define how you want this query to be understood by the system. Like you can possibly define the def type and you can give the query parser of your choice. You have various behaviors which are being exhibited by different query parsers. Okay, so that is why it is advisable to use either the query parser of your choice. You can configure the default query parser. You can override it as well per query. You can choose the number of queries you're wanting to query. Like you used to give something, a query like select so-and-so from this table. So this is something which is going to monitor like what all queries are going to be queried, what all fields are going to be queried basically. And then it is going to hit the index store. From here, you can specify that from which particular point are you wanting to see the search results, like the start index, and you can specify the number of rows which can basically pull out the number of search results from that particular query. You can also have the filter query which is going to work on top of these search results. You can filter out the content as well. Like this is basically controlled by the cached data which is there in Solr. So this filter basically is applying the additional query to that search results which have been given by the index store. And then you can choose the response writer and you can choose how this query should be formatted. Is it clear, guys? Okay, Pramod has another question here. So for a typically say 10 GB data, do you suggest a separate Solr server or something? See, you can essentially support your entire data from Solr. You can use it as the NoSQL database as well, Solr. However, if you want this to be used something like in the existing application which I have been catering to, we have been using MongoDB at the back end. We're just using Solr for indexing. So what we do is we simply would query the data. We would simply pull out the ID, the document ID from Solr, and we are going to take that document ID to MongoDB, and we are going to pull out the entire things from there. So as of now, we are using it as the indexing server in the current implementation, which I have been using. However, there's no one to stop your implementation. There's no one to hold your hand. You can definitely use it as the NoSQL server as well at the back end. Is it fine, Pramod? Oh, okay, all right. So this is the velocity search UI. Let's just quickly query this one so that we can at least get the little look and feel of how this looks like. So this is how my Solr console looks like. It is going to tell me that how many cores do I have, all the information. You have this as the core admin, which is basically going to tell you that how many collections do I essentially have. So this collection is nothing but, or I would rather say core is nothing but the demarcation of the documents which are stored in the server. So you can choose the core from here, and furthermore you can see the stats of each of the core, like how many documents are there, and if it is replicated or not. If you have any admin extra which has been enabled, you can push in the documents. So over here, if you look into, this is the update processor from where I can push in the data. So I can choose the CSV or the document builder or the file upload or the JSON or XML. So I can choose any format of my choice to push in the data. So let's see if I have to push any data. I say webinar, say 12, and I say my title is, my title is, say leveraging search capabilities through Solr and Lucene. Okay, and I simply push the document in. The status 0 means that the document has been pushed in successfully. So let's see, we have the query console as well, which is very, very dynamic and very, very extensive. You can choose the number of other advanced features as well. So you can query simply like webinar 12, and it is simply going to give you the search results. So this is as quick as it can get. You can use the wildcards, all the documents which have been indexed with this webinar thing. Probably we do not have any other document with this thing. That is why it is not listing them. Or I would rather say that I'm looking for simply the web star. So it is going to look into the default query field, which can be configured from your configurations. So as of now, if you look into, you have all the documents which have been listed here. They more or less have the same context. I mean, you have looked for web star, so all the documents which apparently had any version of web, so they are going to be pulled out. So this is the filter query you could possibly use. You have another feature like FL here. You can choose the number of fields you would like to see. So as of now, if I just say that I want to look into only the ID, it is only going to list me the ID here. So this is something which has been provided by Solr. It is not, I mean, the backend obviously is monitored by Lucene, but Solr independently is also taking care of a lot of things which are not really taken care of by Lucene independently. So also we wanted to see this. So I'm as of now querying the Edureka core. So let us quickly look into this velocity UI as well. I hope you guys are okay with extending maybe 5-10 minutes more. So let me just wind things up. Okay. I hope you guys are enjoying it as well. I mean, it's not. So this is how the velocity UI looks like. So it has created the facets for you. You can boost with the price. You can look into the spatial search as well. There are a few of the documents which have the lat long. So basically, you can do the spatial searching here as well. You can do the group by as well. So the configuration for this velocity UI is available in your Solr's distribution as well. So maybe you can modify the behavior of this as well. You have the facets called category here. So you have 12 documents in the books facet. Electronics has also 12 documents. The facet called hardcover has got 9 documents. So you get basically the entire picture of your complete core here. So all the documents which have been ingested in, they're going to be basically arranged in the format the user would want to see on any search website. Is it fine, guys? So this is what basically faceting is. I mean, it is basically the search results arrangement into the categories. I hope we do understand that. These facets which, okay, the ones you were seeing on the velocity UI, Rahul, these facets are not auto-created. If you want the facets or the clusters to be auto-created, you need to enable clustering on your instance, basically. So this is something which is manually done. Okay, Ravi says I have to sign off. Oh, okay, okay. All right, no issues, Ravi. Do provide the feedback if you want anything else to be probably covered. You can let us know. We can incorporate them in the further webinars. So thank you for attending the session, Ravi. So coming back to this, we understand that faceting is nothing but grouping, basically. So it is nothing but the arrangement of the search results in the categories which users find it a little easier to go through. Like you have these categories here. If you look into, we were looking for digital cameras, so we have these categories here which fall into the broad category of manufacturer. So you have Canon, Sony, Nikon. So you have all the cameras which belong to these particular manufacturers. So you could further refine them on resolution, zoom range, and further other features. So these are all the filters. The Canon, Sony, Nikon are basically the filters. Okay. Then you have further pivots here. So pivots or the breadcrumbs, which can basically show you that how many filters have you really applied. Okay. So this is the facet count, like how many documents were there in each of the category. And this is basically going to tell you the each document which has been pulled out from each of the category. So faceting more or less is like a grouping. So this is another example of the grouping. We could have the grouping on price ranges. We could have them on the binding. We could have them on the date of publishing. We could have them on the languages as well. This is for the books data. So you might have something like this as well. Like if you might have seen something like the hotels data as well. You have something like the price ranges of per night stay. What is the user rating? What are the facilities which have been given? If free Wi-Fi is there, if food is there, if breakfast is included and stuff. So these are a few of the examples of the facets. So okay, Pratap is asking, would there be any handouts? This presentation is going to be distributed as a handout, Pratap. So we're going to quickly devote, say, 5-10 minutes on the cloud version of Solr. Okay, then we are going to simply disperse. Is it fine, guys? I'm not going to take any more time, even I'm feeling thirsty at this time. So SolrCloud version is basically there to, yeah, only 10 minutes. Okay. So SolrCloud version is basically there to make sure that if we want to have the distributed search capabilities there. So we can basically set up the cluster of Solr servers, which can basically deliver the fault tolerance and the high availability feature to your application. So it is very, very flexible. Again, it gives you the feature of distributed indexing and searching without any master node allocated to any of the node clusters. So you have nodes, you have shards and replicas here. So nodes are all the machines which have the Solr's distribution, which has been installed on it. Shards are basically the logical slice of each of the core or collection, which we have just discussed. And replicas, as the name suggests, is the replicated form of that shard. So there's the zookeeper, which is basically there, which is integrated in Solr to make sure how the cluster has been managed. So this cluster management is completely taken care of by zookeeper. However, no one really stops you. You can use any external cluster management as well. Okay. So if you're sending any document to the server, this zookeeper is going to figure out that which node it should ideally go to. So we have this mechanism wherein we have the leader and we have the replicas here. So replicas are there to take care of any read request. However, the leaders are the one who can only write to any particular collection. So just to ensure the consistency and no concurrency error should be thrown, every shard is going to have only single leader. However, you can have multiple replicas just to ensure the high availability of the data. So this is how your architecture of cloud looks like. You have millions of documents which are going to be ingested through your REST APIs or through a cron job or whichever way you would want to figure out the way. And then it is going to be sent to the Solr server. So it is the load balancer is integrated in the SolrCloud mode, and you have say server 1 and server 2, which are essentially taking the single collection example which we have taken. We have got just one collection here, and we have shard 1 and shard 2 here, which are the logical piece of this collection only. Okay. So we have shard 1 and shard 2, which is comprised of collection, a single collection basically. So both of them together make one single collection. So we've just separated them on the basis of hash ranges just to ensure that it is highly available. Both of them are going to be writing data to a single collection, but different shards. And in server 2, we are maintaining the replicas of these. So this is as per the concept of the replication, we are maintaining the replicas. However, we have distributed them in shard 1, leader shard, and shard 1 replica shard. This is the process of the sharding. So this is nothing but distributing the collection into different pieces as per the hash ranges. And then you have the zookeeper. We would have multiple instances of zookeeper inside this central configuration management, just to ensure that zookeeper itself doesn't goes down. So the zookeeper makes sure that how this leader has been elected and how this data has been routed to leader. Okay. So this entire things are being taken care of by your zookeeper instance. And there are then millions of users which are going to interact with your Solr Cloud version through your REST web services, which have been exposed by Solr itself. So how can you use Solr with Hadoop is that obviously Hadoop provides you with very efficient mechanism of storing the data. So definitely the indexes are going to be stored somewhere. So just to ensure that your indexes are stored and you should not have any memory constraints, you can use Hadoop. You can use any other NoSQL database at the backend as well, just to ensure that your indexes are integrated, are basically maintained with the integrating. However, you can also have something like that the indexes are being stored on Hadoop, and you have the map reduce or the pick job running just to ensure that data has been nicely arranged. Okay. So you have all the major versions of Hadoop like Cloudera, Hortonworks, and MapR, in which you can integrate the Solr. So this takes care of your data management issue. This is how this scalable indexing would look like. You have data which is coming in various formats. They're going to be pushed into your HDFS. Okay. On this, we are going to run through the process of indexing. Okay. This is also taken care of by Solr. And you have MapReduce job, which is basically going to convert these raw files into the indexed files. And then you can have your search interface, which can be exposed, and you can query and you can get the response from this Solr instance. So instead of interacting with the file system index tool, it is going to interact with the Hadoop file system. Is it clear, guys? Any confusions here, guys? Yes, no, maybe? Guys, are you still with me? Okay. So these are basically job trends of Solr. So obviously this is something which might be of interest to you guys. So I mean, if you notice here, the job trends have been increasing since it has been introduced. Okay. So it's quite hot, in fact, I would say, and you can trust the Solr's scalability. It's unmatched. So you have, I mean, this is the most widely used search engine as of now, which is present. You have approximately, 8 million plus downloads, which happen. You have 250,000 plus downloads, which happen every month, and you have approximately 2,500 plus, open Solr jobs, which are there in the market as of now. It has been used every day by, various giants like LinkedIn, Apple, Netflix, Instagram. So these are very popular applications, and it is catering to almost 100 millions of requests every day. So any confusions, any other further questions, guys? Any other question, guys? So that we can call up the webinar, I'm sure. Okay, Vijay Sen has a question. Thank you very much. Yeah, thanks to you as well. Is there any certification course for Solr? Yes, we provide the course for Apache Solr in with Edureka. So if you might have noticed, we have this as the. Can you not hear me, Uday? Can you all hear me, guys? Okay. I'm not sure. There seems to be some problem at your end. So we have this LMS, which is going to be given, the lifetime access is going to be given to you with Edureka. So all the courses which you're going to enroll in for, they're going to appear in your home page. So you have a lot of accessibility. Plus, if you have any issues, you get lifetime support as well. Okay. So when you enroll in the course, you can look into the pre-recorded classes. You have 8 modules overall for this particular course, and for each of the modules you have the quizzes, you have the exercises, and in the end you have the project discussion. So when you deliver this project discussion to Edureka, you get the certification for this, which can be added to your LinkedIn profile as well. Does that answer your question, Vijay? Does that answer your question, Vijay? Okay, great. Any more questions, guys? So thank you so much for being such a nice audience. Yeah, thank you so much, Pramod, to you as well. Okay, so hope to see you all in the batches to come. Okay, yeah, thank you so much, Rahul, to you as well. Don't forget to provide the feedback as well, guys. Yeah, thank you, Preetham. So do provide the feedback, guys. We would be looking forward to it. That helps us improving, and if you want anything else to be added, do pen it down. Thank you so much, guys. You have a good night or have a good day. Okay. Thank you so much. Bye-bye.